Yeah, already we done sets, relations. From that sets and relations, we will get define functions. Yeah, set means what? The collection of well-defined elements. We are writing in the between parentheses is nothing but a set. Relation means a set of all ordered pairs whose ordered pair elements are in a set two sets A and B. That is A cross B equals to AB such that A belongs to capital A, B belongs to capital B. So that is the relation. Now here function or mapping. Here this is can be write it as, first of all it is compulsory a relation. A relation will convert into the function. A relation F from a set A into a set B is said to be a function or mapping. Function or a mapping from A to B. If for each x belongs to A, there exists a unique y belongs to B, such that x comma y belongs to F. Yeah, this is A set. This is B set. There will be a function between A to B. Okay. This F is a function from A to B. The condition is each x belongs to A. Each x belongs to A. X. Every element in X. Okay. There exists a unique element of Y in B. There exists a unique element. Okay. Each x belongs to a unique element. Unique Y in B. Y belongs to B. So that time it is a function. The relation means not like that. Every element in A are mapping with any element in B. Here, function means every element in A are mapping with a unique element in B. Unique element. Unique element means, for example, wise here A set 1, 2, 3. Here a B set A, B, C. Yeah, one maps A, one is mapping also B, 2 mapping B, 3 mapping C. Okay, so F be the function from A to B. Yeah, it is a function. No, it is not a function. Why? Because yeah, every element in A are mapping with the elements in B, but not unique. One is mapping with A and B. So A and B both are not equal. When these two are not equal, here f of 1 equals to A and f of 1 equals to B we got. So what I'm saying here, each x in A, unique y in B. So every element in A are mapping with the unique element in B. So that means what? Here 1, 2, 3. Here A, B, C, D suppose. 1 mapping to A, 2 mapping B, 3 mapping C. This is A, this is B, F. F maps, this can be write F maps A to B. This is called a function. This is called a function. This can be write F maps A to B. Yeah, I will write the definition is a relation F from set A into set B into a set B is said to be a function, is said to be a function or mapping. Function or mapping from A to B, from A to B. If for each x belongs to A, there exists a unique y. A unique y belongs to B, such that x comma y belongs to F. Belongs to F. It is denoted by F maps A to B. That means that's it. Yeah, here, this is the definition of that. And next point is, if f maps A to B is a function, f maps A to B is a function, and x comma y belongs to f, then y is called, that means here, A set, here, this is B set. X in A, y in B. There is a function f. Here, y is called f image. This is called f image. Here, x is called f inverse image or pre-image. Pre-image or inverse image. Are you understand? Mathematically, we
Yes,
are writing the function definition is, mathematically we are writing the function definition. A relation f from a set A to B is said to be a function or mapping from A into B if the conditions are x belongs to A, there exists f of x belongs to B. Unique. This is unique. And the second one is unique means what? X1 comma x2 belongs to A. X1 comma x2 belongs to A. If x1 is equal to x2 is implies their f of x1 is equal to f of x2. The mapping elements also equal. If these two are not equal, these two are also not equal. That is called a function. And of course, all the elements in A are nothing but domain. All the elements are B are a codomain. What are the elements are mapping with A? Those elements are range. Suppose here A be the set, B be the set. Here 1, 2, 3. Here A, B, C, D. 1 maps A, 2 maps B, 3 maps C. F be the function. All elements in A are mapping with unique element in B. So these all the elements in A are nothing but domain elements. All the elements in B is nothing but codomain elements. Codomain elements, but ABC are ABC only here ABC are mapping with 1, 2, 3 are range elements. Okay, the codomain in the codomain elements, all elements does not mapping with the A elements, capital A elements. A elements means a set A elements. Some of the elements are there is a chance to not mapping. Okay, those what are the elements are not mapped elements with A, those are nothing but codomain elements but not a range. Yes. Now types of functions. First one is 1 1 function. 1 function. 1 function means what? 1 or injunction.
an element from any, like the first set, like from domain, has a unique image, unique and different image in codomain.
Every element in X are mapping with the different elements in B. That means if x1 comma x2 belongs to A, x1 is equal to x2, their mapping elements also f of x1 equal to f of x2. X1 is not equal to x2, then f of x1 is not equal to f of x2. When this condition is satisfied, that is 1, 1. That means what?
So can you repeat again?
Yeah, here A, here B. This is A set, this is B set. 1, 2, 3, 4. Here A, B, C, D. 1 is mapping with A, 2 mapping with B, 3 mapping with C, 4 mapping with the D. This is F. Different elements in A are mapping with different elements in B. So this kind of functions are 1, 1. Are you understand?
Yes, sir. Sir, in codomain, do all the elements need to have a pre-image,
No,
or
yeah. In this one, some elements will be suppose EF. Of course, it is one. EF is not mapping with any element in A. Okay, the codomain and the range both are not same. Of course, it is a one. In the onto function, compulsory codomain and the range. Onto function means our
so all the elements in codomain must have a pre-image?
if f maps A to B is onto, if f maps A to B is onto our surjection A to onto, if and only if y is belongs to B is m plus there exists x belongs to A, such that f of x equal to y or y equal to f of x. So that means what? Here A, B, C, here 1, 2, 3. A is mapping with 2, B is mapping with 1, C is mapping. Here this is F, this is a set here, this is here set B. Simply what we say here, codomain equal to range. All the codomain values are mapping with at least one element in A. Okay, for example, in a theater, all the seats are assigning with the persons is nothing but onto. All in theater, in the seminar hall or in a classroom, all seats are filled with the persons, filled with the students, or filled with the persons, then it is nothing but onto. Suppose some chairs are not filling, that is nothing but one. Yeah, each compulsory the chair assigning with only one element. The chair does not assigning with the two elements, two persons. Suppose a chair can be assigning two persons, that is not a function. That's why the x values, the x belongs to A. Each x value in A are mapping with the unique value in B. Unique, only one. Single seat for single person. Single seat assigning for single person. The one seat, no two persons will be mapping. So suppose one person will be mapping with the two persons, that is not a function. Here codomain and range both are same, then that is nothing but onto function. Yeah. Are you understand? Atiri?
Yes, sir.
Next, bisection. Bijection function, when a function f maps A to B is satisfies
Both
one
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 and onto function.
one and on. When these two conditions are satisfied, then that function is nothing but bijection. Here some points we have, you see here. If f maps A to B is one, A and B are both are finite sets, then n of A, number of elements in A less than or equals to number of elements in B. And if A comma B are two finite sets, if A comma B are two finite sets, then the number of one functions, then the number of one functions that can be defined from A to B, that can be defined from A to B is n of BP P n of A. This is the formula. Number of one functions we are calculating between A to B. Suppose A having 6 elements, B having 7 elements, then the how many number of one functions means 7p6. Yeah, NPR formula we have. NPR means what? N factorial by n minus r factorial. Are you understand this point? Can I explain with an example? Atidi, Atidi,
Yes, sir.
can I explain one example or you can understand this?
So can you explain an example?
Yeah, A having some 8 elements are there. Suppose 1, 2, 3 up to 8 elements. B having 1, 2, 6 are there. There will be a function. A function is defined from A to B. Atidi, tell me, there is a possible to define, there is a function from A to B. N of A is 8, N of B is 6. Tell me.
So your voice is breaking. Can you repeat again?
Are you understand what I am asking you?
So can you repeat the question? Your voice was breaking.
No, not this. Just you. I am asking you generally. A set having 8 elements, B set having 6 elements. There is a possible to take a function from A to B. Is there a possible?
Yes, sir.
Why? How it is?
So if we
What is
take
meant by
n
function?
of A
Each and
and
every element in A are mapping with a unique element in B. Is it right? Here 8 elements are there. Here 6 elements are there. Here 6 elements mapping with 6 elements. But so what about 7 and 8? So it is not a function. Huh?
okay.
Are you understand?
Yes, sir, got it.
Here n of A equal to 8, n of B equal to 6. By the definition of function, each element in A are mapping with unique element in B. Unique means only one element in B. But here n of A is 8, n of B is 6. It is greater than more elements here. Here what I am writing here, n of A less than or equals to n of B. But here n of A greater than n of B. It is not a function. We cannot write the one also. Yes, you see here A having A, B, C, set B having 1, 2, 3, 4. Yeah, there will be a chance to write the one function and function also. Okay. Yeah, now here n of A equal to 3, n of B equal to 4. Yeah, n of A is less than n of B. Yeah, there will be a chance to write one functions. So how many one functions means n of B, P, n of A. That means 4p3. So 4 factorial by 4 minus 3 factorial. This is 24. 24 possible ways. A mapping with 1, that is one way. This is one way, this is one way. A mapping with 4, B mapping with 3, C mapping with 2, that is one way. The number of mappings, the number of possible chances, the number of possible ways to get one functions. Are you understand, Aditi? For getting one function, the compulsory A set having less than or equal to B set. You know.
Yes, sir.
Hmm. Reversely onto function. If I f maps A to B onto function, and n of b equals to 2 if the set B having only two elements, then the number of onto functions, then the number of onto functions that can be defined from A to B, that can be defined from A to B is 2 to the power of n of A minus 2. This is one of the formula. And here two finite sets A and B. If F is onto n of B is less than or equal to n of B. Here n of B less than or equal to n of A. For getting onto. If F is bijection, n of A equal to n of B. The number of elements in A, number of elements in B, both are same. Yeah, that is for bijection. Now here composite functions, how the composite functions will be defined. Suppose if F maps A to B, G maps B to C are two functions, then G circle F maps A to C is composite function. Composite function. It is very, very important. The question will come in this. Suppose this is set A, this is set B, this is set C. A, B, C. There is a function between F, here G. Now from C to A also, the function G circle F. This is composite function. And F, if F comma G are 1, 1, then G circle F is 1, 1. Okay. Both are onto, then G circle F is onto. If it is bisective, then G circle F also bisective. G circle F also bisective. And now here, three functions when we are taking, three functions. F, Z, H. If F maps A to B, G maps B to C, H maps C to D. That time the composite function is H circle G circle F equals to H circle G circle F. H circle G circle F. Suppose here, how we are finding this? If F of X equals to 2x plus 1, G of X equals to X square is there. Then we need to find G circle F and F circle G of X. So what? So first one is G circle F of X. This can be right G of F of X. So that g of here what f of x is there. F of x means 2x plus 1. 2x plus 1. Yeah, g of 2x plus 1 we find. G of x is x square. In place of x is 2x plus 1. We put in place of x is this 2x plus 1 whole square. This is called 4x square plus 1 plus 4x. That is G circle F. Now write F circle G of x. This is F of G of x. So F of G of x is x square. Now f of x is 2x plus 1, but here f of x square is there. 2 into, in place of x is there x square plus 1. We got 2x square plus 1. And a similar way we are getting fzh also. Fzh. F of g of h of x equal to h of g of f of x. Yeah. Sometimes g circle f and f circle g both will be equal. Next, identity function. How we are writing the identity function? This is important for inverse function. Inverse function, without inverse function, there is no competitive paper. Compulsory will get inverse functions. Okay. Now, what is meant by identity function? If A is a set, if A is a set, then the identity relation I on A is on 1 1 on 2. Then identity relation I on A is 1 1 on 2. 1 1 on 2. Now, how we are defining the identity function? If A is a set, then the function I on A, then the function I on A defined by I of x equal to x. The same I of x equal to x for all x belongs to A is called identity function on A. Is called identity function on A. It is denoted by IA. That means what? IA is a function from A to A. So this is called identity. Then we are write IA. B is a set. The identity function on B is I maps B to B. This can be write IB. And now F circle IA equal to IA circle F equal to F. Here IB the identity. Similarly, F circle IB equal to IB circle F equal to F. Why? Because IA and IB both are identity functions with respect to the A to A. Now we are writing inverse function. For getting inverse function, compulsory F is bisection. If F maps A to B, F maps A to B is bisection, then the inverse relation, F inverse, relation F inverse from B into A, from B into A is also bijection. Yeah, how we are define F inverse? F is a function from A to B. Then the inverse function is F inverse maps B to A. Here domain, here codomain. Here codomain, here domain. Reversely we are writing. F inverse of y equal to x is implies y equal to f of x. The inverse function is like that. Suppose y equal to x square plus 1 we write. X square equals to y minus 1. X equals to y minus 1 whole square. To put in place of x is y minus 1. Then we are getting the equal. X square equals to y minus 1. X equals to y minus 1 whole square. X equals to f of y. X equals to f inverse of y. Here y equal to f of x. This is called y equal to f of x. Here x equal to f inverse y. That means inverse function. Yeah, inverse function is very, very important. We will teach so many problems, and the inverse conjugate functions also there. How the multiplicative inverse function with respect to the identity between A to A, B to B also we will take. Without the inverse function problem, there is no competitive paper, either MSET or JEE mains and advanced, whatever it is. The inverse function compulsory given. One function is given, what is the domain and codomain of the inverse function of that function. Okay, f is given 1 by x square plus 1. Then first we are finding f inverse, after that the domain and the range of the f inverse. Okay, that is the important thing. We will teach. The maximum time is over. We'll meet again on next class. Atidi, I hope you understand. Atidi, tell me. Atidi, are you understand or not?
Yes, I got it.
Yeah. Bye, Nana.
Thank you, sir. Bye.
Bye.